When it comes to civic structures like palaces and residential this thing, many people have a question. Some people have asked me, see, when we travel to Europe and other places, we find a lot of palaces and secular structures in great number along with churches. But what happens in India, probably much importance was never given for worldly matters. And the palaces were mainly built with wood. And that is why many of them have perished. And even during Vijayanagara period, there are travelers who have recorded how 7-storied palaces were built with only wood. You are heard of Brihadeeshwara temple in Tanjavur. The height of the temple from the plinth is 200 and odd feet. The superstructure itself is 180 and odd, so below that. The entire structure is standing on the ground, and the foundation beneath the ground level is just 5 feet.
आज का पहला सत्र है केमिस्ट्री इन एंशिएंट इंडियन केमिस्ट्री इन कंस्ट्रक्शन मटेरियल्स। भवन निर्माण में अथवा मंदिर निर्माण में जो औषधि वस्तुओं का जिन सामग्रियों का उपयोग होता है उनमें भी केमिस्ट्री प्रचुर मात्रा में आती है। उसमें उदाहरण के तौर पे आज अगर आप किसी घर को बनते हुए देखेंगे तो उसमें सीमेंट का प्रयोग होता है। सीमेंट बालू का मिक्सचर पानी डाल करके उसको एक ईंट के ऊपर एक लेप लगाते हुए उसके ऊपर दूसरा ईंट का चादर चढ़ाते हुए चलते हैं। वो अभी तो ये सीमेंट और बालू का मिश्रण कॉमन सा है, बट आज से 1000 साल पहले क्या ऐसे ही भवन एवं मंदिर के निर्माण होते थे? उत्तर भारत में आप बहुत सारे ऐसे मंदिर देखेंगे जहाँ पे ईंट से मंदिर बने होते हैं। आप लोगों में अगर किसी ने यहाँ पे देहात में कहीं देखे होंगे या फिर अभी लंका में ही, लंका से अगर संकट मोचन की ओर जाएंगे तो पुराने महल मिल जाएंगे जो ईंट से बने पड़े हैं, जो आधा खुरेदे हुए हैं, लेकिन उनमें देखेंगे कि वो सीमेंट से नहीं है, कुछ और उसमें लेप लगा हुआ है। उसी तरह अगर आप किसी दक्षिण भारत के मंदिर को देखेंगे जो कि पत्थर से बना होता है, 2 पत्थरों को कैसे आपस में जोड़ के रखा जाता है, उसमें क्या सामग्री का प्रयोग होता था, इसी विषय को चर्चा करने के लिए हमारे मध्य उपस्थित हैं 2 ऐसे वरिष्ठ मनीषी, डॉक्टर मनोज गुंडन्ना जी जो मंदिर के निर्माण कला के विशेषज्ञ हैं और हमारे यहाँ पे कर्नाटक स्टेट बेंगलोर से पधारे हैं। मैं सादर आमंत्रण करता हूँ उनको आए और अपने मंच में अपना स्थान ग्रहण करें। उन्हीं के साथ हमारे यहाँ पे हमारे बीच आज जुड़े हैं डॉक्टर पीवी सुरेश कुमार जी जो केरला के वास्तु विद्या गुरुकुलम नामक संस्थान में सीनियर साइंटिस्ट हैं और ये प्रैक्टिसिंग आर्किटेक्ट भी हैं। और ये एक और अनोखी बात यह है कि ये भी IKS सेंटर के एक प्रिंसिपल इन्वेस्टिगेटर हैं। मैं सादर आमंत्रित करता हूं, आई रिक्वेस्ट डॉक्टर पीवी सुरेश कुमार टू प्लीज कम एंड टेक अ सीट ऑन द स्टेज। और मैं वी रामनाथन इस सत्र का संचालक बन के आपके प्रस्तुत करूंगा। धन्यवाद। As it is a section on chemistry of construction materials, and this is designed as both a panel discussion come a presentation. So I will be having some questions to our esteemed panelists, and I leave it to their discretion to use the PowerPoint or without the PowerPoint to address those issues. First is, besides stones, what other materials were used in constructing temples? So we will start with sir.
Namaste to everybody. So temple building has been a very age-old practice in India. To understand what was the medium used to build the temples, we will also have to know some literature part. So the existence of temple is known as early as the Ramayana itself. So there is a mention of temple and temple culture in Ramayana. But what happens? Usually we need some structural evidence to decide about the antiquity of this particular culture. So the antiquity of this dates back to say first or second century, the pre-common era, before the common era or the BC as it was used to be. Why was it so? Because from that period onwards, the medium of stone was being used to build the temple structures. Prior to that, the temples were built with a lot of wood, primarily wood, with the support of brick and mortar. So this is known even through the Vastu Shastra Granthas or texts which deal with building technology. See, in Indian literature, we have one branch of knowledge which is called as Vastu Shastra, which deals only with the building technology. In that, again, we have two branches. One which talks about the temples alone, the second which talks about human residence, town planning, planning of a village, all these things are discussed. So usually a Vastu Shastra Grantha will mainly concentrate upon temple building, and then it talks about Nagara Nirmana, Grama Nirmana and other aspects. You need to know this, understand this background before I talk about the material. That's why I am mentioning. This is the source from where we get to know what are the materials. So there are texts like Mayamata, Kashyapa Shilpa Shastra. Of course, Manasara is a very popular text, but it's a quite later text. The earliest one, which is in complete form and without any confusion, is Mayamata. All these texts begin with the selection of the ground to build a structure, and they also talk about the various materials that is used. So usually structures are classified into 3 in some texts, 4 in some texts. So the first one becomes Shilamaya, that is one which is built with stone. Other materials are, it is Darumaya, Darumaya one which is built with wood. So the entire structure was built with wood. See, Megasthenes, the Greek traveler during the Mauryan period, he says that the entire Pataliputra fort was built out of wood, and all the buildings and structures were built out of wood. Then we have, so that is the Darumaya, this thing. Then some texts just mention one Ishtaka. Ishtaka means with bricks. Naturally, no structure will be just with bricks. You will have to apply something like mortar or something like that. That is understood. And the fourth one is the Mrinmaya. Mrinmaya means mud structures. But what happens? The fragility of the latter 3 things, that is wood, brick and mud, they are perishable materials. They are not long lasting. So that is why after one period, the sculptors decided to rely upon stone, and stone is being used from the, is being used more. So therefore, apart from stone, we find temples were built in brick and mortar as well as wood. And we still have some remnants of very old structures, at least in Karnataka I can mention. There are some remnants of structures of Ganga period, where we have the stone was used for door jambs and wherever beams, wherever strength was required, and the rest was built of brick and mortar. Such evidences we have. So brick, mortar, wood and mud were also used for buildings. When it comes to civic structures like palaces and residential this thing, many people have a question. Some people have asked me, see, when we travel to Europe and other places, we find of palaces and secular structures in great number along with churches. But what happens in India, probably much importance was never given for worldly matters. And the palaces were mainly built with wood. And that is why many of them have perished. And even during Vijayanagara period, there are travelers who have recorded how 7-storied palaces were built with only wood. The basements were made of stone to give stability. Wherever necessary, stone was used. Otherwise, wood was prominently used with brick and mortar. So this is about the building material.
Thank you, sir. I would request Dr. Suresh to comment upon this question.
Regarding the traditional materials, I wish to show you a PowerPoint presentation. These are all traditional buildings. Traditional buildings means from hut two temples, very big buildings also constructing in a traditional way. That is the pictures, some pictures I am showing. These are all, this is comparatively a big house that is also constructed based on traditional material as well as traditional concepts. This is a traditional house with 3 stories, constructed with the laterite stone, 3-storied building. This is 400 years old. This is temple. It is also more than 800 years old. This is Aramala temple, that is more than 1000 years old. What is the advantage of this traditional material? That is one important thing. Why we have to go for traditional material? Now, what is the peculiarity of traditional buildings? The advantages are good atmospheric condition. It was very good atmospheric condition. When we are living in a traditional building, we feel very calm and quiet, very cool atmosphere. When warm, in summer season, we feel a cool atmosphere, and in winter season, we feel a warm atmosphere inside the room. It completely follows the sustainable concepts. Now we are, Western countries also going for sustainability. 2000 years before, Indian people practicing this sustainability concepts. That is what I wanted to say. Environment friendly. It is very environmental friendly. Now it is reiterated that it is very environmental friendly. We are using locally available material. It was very good durability. Selection of material and method of construction based on the local availability and the outside atmospheric condition. We are just, we are not at all, now we are constructing a house and putting one air conditioner. That is the practice. But before, we are selecting the material as well as the concepts based on the local availability as well as the local land atmospheric condition. The disadvantages are skilled supervision required for the selection of material as well as for type of construction to be adopted. There is not much training or courses available for traditional construction. There is not much quality control or testing lab or standardization for this selection of material as well as the selection of concepts. Now, IKS-AICT provide too much input to promote the traditional knowledge in all aspects. We made a lab in our Vastu Gurukulam. The traditional materials are daru, mritsna. Daru means wood. Mritsna means soil. Mrillostam means the burned tile or brick. Then loham, that is metal. Shila and Sudha. Sudha means lime mixed with the sand. In the Indus Valley civilization 2500 BC, majority of construction done by fired bricks or some by sun-dried bricks. That is a planned city. Actually, we are doing research on this mritsna. Mritsna means soil. That is, with soil, we could achieve all the advantages of these traditional materials. Before also, some soil construction there, how they constructed, we don't know. That is a problem. There is some other huts only. Now it is remaining for showing that soil construction. Some other constructions are also there. The rammed earth has been used in India for the construction of walls since several centuries. Construction of Great Wall of China in 3rd century. It is used in Europe in 7th century and Himalayan region and Tibet around 8th century. Hundreds of years of old buildings in Middle East, also examples of this earthen construction. As per Vastu concepts, for the construction of temples, clay and bricks are not acceptable in our area. The belief is due to the presence of dead bodies of living things. As per scientific findings, about 80% of the soil used for making clay and bricks have particle size less than 0.002 millimeter size, which is the material size required to absorb through the roots of the plants or trees. By burning, the strength is achieved by the combination of the smaller size particle to bigger size particles, but there is a very heavy danger is there. By burning, the hidden dangerous process happening for the earth is the conversion of the most fertile soil to the most infertile soil. So, clay and bricks now banned fully. What is rammed earth? Rammed earth is form of unbaked earth constructions. Unbaked, that is very important because the fertile soil should not convert to infertile soil. By disintegration of the building wall or building part, structural member, it would possess the original condition, chemical condition as well as physical condition by disintegration. That is the advantage of this mritsna. And we put some technicality because sometimes it might be used in before also. We don't know how it is using. That is the problem. It need the processed soil. That is why it is written as processed soil. Some gradation of soil is required. Soil compacted in layers to form a component of a building. Structure is termed as rammed earth. Formwork become essential for the rammed earth construction. Walls, foundation, floors, built-in furniture, etc. we can construct with the rammed earth. Types of rammed earth. Unstabilized rammed earth without, that is without inorganic additives. Stabilized rammed earth with organic additives. But for stabilized rammed earth possesses wet strength. Instead of cement, we can add some organic materials like maybe chance there to add some Ashtapanda or Brihadeeshwara with another materials also. But it is very, very expensive. That is a problem. Otherwise, we can do, I think, with the research I am telling. For the construction of RE walls, processing the soil, setting the formwork, compacting the processed soil and curing. That is the 4 stages required. This is technical terms. That is why the compressive strengths we achieved. That is some graphs. How this optimum gradation we find out. That is another graph because the green line shows sample 1 and bottom line shows a sample 2, and with optimum strength how we achieved, that is explained here because you see in the graph the top between this red line and green line, the gap is almost double than that of the bottom one. So the bottom sample soil 2 times and the top side soil 1 time if we add, then we get the optimum grading of that soil. That would possess more strength and more durability. This is a compaction related to that how we achieve maximum compaction. The things is characteristics of CSRE. It depends mainly on the density. The second part, the moisture content of that material. Third one, clay fraction. Fourth one only the cement content. Because cement content is not much influential for the strength or durability of rammed earth. Because 20% increase in density causes 300% increase in strength. But for cement content, 30% if you increase, 20% only it would increase. That means cement is not the criteria, not much influential for the strength and durability. This is a school building constructed by Professor, my guide, Professor B.V.V. Reddy, 3-story building with rammed earth. The classrooms are of size 7 meter by 7.4 meter, and there is no RCC slab over the roof. It is just like a funicular arch. During Bhuj earthquake rehabilitation, since this rammed earth possesses actually 40% more strength than that of brickwork or blockwork, because it is constructed in a monolithic way. It is continuously constructing. So due to that monolithic action, it possesses 40% more strength than that of brick or blockwork. That is why in Bhuj earthquake rehabilitation work, this rammed earth is used, because it possesses more strength. It can we can achieve any strength, or we can design for strength also. That is the advantage of this rammed earth. These are all Kutch Navadarman Abhiyan Gujarat, designed by IAC. This is all, this small huts are constructed during or after the earthquake. It is earthquake resistant also because of this monolithic action. 3,000 houses built in 2 years. Design of rammed earth wall needs information on characteristic compressive strength, capacity and strength reduction factors for slenderness effect. For both these two, we published a paper in American Society of Civil Engineering, and in a Springer series also. This loading frame donated by France for our project. For European Indians are very cheap. That is why they are providing some fund and providing some machinery. We are doing research, and we are giving the results. That's all. There are large numbers of modern rammed earth buildings which have been built in the last 3 decades. One is my own house. After constructing my own house, I started consultancy, because by research only, if we are some paper we publish, then people would not believe whether it is good or not in paper only, or it is actual practice, whether it is. This is my rammed earth house. The bottom flooring also by rammed earth. The bottom top one is by wooden paneling. These are all earthen house, earth only, soil only. This is a house constructed in Vallangolam near Manimala River, near to banks of Manimala River. Every year, flood would come up to 1 meter to the house. This is fully constructed with rammed earth, and the top tile is with reused tile, 120 years old. Advantages of rammed earth: inside atmosphere is same as other traditional houses. Strength is 40% more than brick or blockwork due to monolithic action. Durability test shows much durable. Member can be designed for strength as well as for the shape. Recent study shows 85% of soil can be replaced by crushed, demolished building waste without cause any change in strength or durability. These are demolished waste. We crushed this one by gradation. We constructed this IKS building lab. That IKS lab equipments provided by IKS. Getty Mutiji selected us for this. Madam also came there. The process is, I showed this one. There is another suggestion also. Yesterday I saw some building waste in IIT Varanasi also there. We are ready to make some building with that building waste also, if you are agree with this one. These are the lab provided by IKS during this for testing. These are the specimens with actually for in Mayamada we are doing research we plan to do research on 2 years with Mayamada explained one stanza with that one stanza, we are doing research in 2 years. And for other stanzas, many people can do, many means thousands of people can do research on each line, I think, because that much vast subject is. This one, Ashtabanda Samgrahanam. Lachaguna Madhuchista Gugulanam Samamsaga Yetesham Sugunam Dugunam Bhagam Grahyam Sarjarasam Tada Gauriga Churnagam Tasmartham Tu Khana Churnagam Sarveshamartha Tailam Nichiveloha Vajane Loha Dravyachalam Kuryat Vajayen Mrudu Vanina Ashtabandam Idi Prokta Masmavat Dridabandhanam. This wax, jaggery, kolaraka, in our area it is kundirikam, sarjarasam, gauriga churnam, that is seashell powder, with some cotton also using. Ashtabanda, the permanent organic glue we are using in the Silparatna as well as Tantra Samchaya, it is there, Mayamada, other than Mayamada. The 8 organic ingredients are seashell powder 6 parts, Chenjalium a herb 4 parts, Kaduka Myrobala 2 parts, Kolaraka Lacifer Laka 1 part, Kodiparale herb from river Bharada river 1 part, dry amla Indian grocery half part, river sand 1 part, dry cotton flower free from seed 1 part. Actually, seashell is this one, dry amla, this one, kaduka is this one, cotton, then river sand, chenjilium, that is just like just like latex from rubber tree that we get, chenjilium, that is a resin. Then kolaraka, then kodipara. These are the ingredient of that Ashtabanda. Ashtabanda, when after preparing Ashtabanda, if we put it in water, it is insoluble. Water color will not change. That is a testing method for Ashtabanda. All other things, if we put in water, color would change. But after making Ashtabanda properly, if we put it in water, that water would be clear for ever. That is the thing. If the preparation is correct. These are the specimens prepared with the Ashtabanda with some additional material that in the proposal of that project. These are the specimens prepared with the Ashtabanda only. For testing purpose, we need a specific size and a specific shape. That is why we prepared this one. This is, you see, a Kodiparala. When we open this one, its color would be just like sky blue. It is very fantastic. It's when we break it, inner side of that one be in sky blue. This is the hammers used for making Ashtabanda. Hammering Ashtabanda need 1 lakh hammering for each mix. That is the main cost of this Ashtabanda become very high. Thanks a lot.
Thank you, Dr. Suresh. I think most of the questions that I had further to ask, I think most of them were already covered, so I'll not bother you with further questions. For the benefit of students here, कल शाम को आपने एक कथकली का प्रस्तुति देखा था जिसपे वो अपने चेहरे पे कैसे रंग चढ़ाते हैं. तो कुछ जिन्होंने अभी चेंचुलियम जिन्होंने बताया अभी सुरेश जी ने, आपको याद होगा कल वो आर्टिस्ट भी उसका उल्लेख कर रहे थे. तो इससे यही पता चलता है कि जो हमारे इर्द गिर्द में जो हमें उपयोगी वस्तु हमें दिखा था, उन सब का हमने कहीं ना कहीं प्रयोग किया है. वो चाहे नृत्य के रूप में रंग चढ़ाने के विषय में हो अथवा इवन भ्रमण निर्माण में हो. ठीक, तो इसके साथ मैं डॉक्टर मनोज जी से ये आग्रह करूंगा कि वो पारंपरिक रूप में, जैसे अभी सर ने बताया कि हम कैसे मटेरियल के स्ट्रेंथ को डिटरमिन करते हैं, कुछ उन्होंने ग्राफ्स दिखाया जो सॉइल के प्रॉपर्टीज और जो मिक्स करने पे कैसे उत्तम सवालात, वो आज हम आधुनिक तकनीकियों से पता लगा सकते हैं। बट आज से पहले, 1000 साल पहले जैसे टेक्निक्स नहीं थे, तो मंदिर को निर्माण करने के लिए जो पत्थरों को चुनते थे, वो किस आधार पे उसको उनका चयन होता था, उन मटेरियल्स का कैसे टेस्टिंग होता था। आज हमारे पास लैब है, आज IKS सेंटर सुरेश जी को इस तरह से फैसिलिटीज प्रोवाइड कर रही है, लेकिन 1000 साल पहले हमारे स्थपतियों के पास ऐसा क्या था जिससे वो पत्थरों का चयन करते थे और उन पत्थरों से, चयनित पत्थरों से ऐसे भ्रमण का और मंदिरों का निर्माण किया जो कि हजारों वर्ष तक टिका रहा। तो ये सवाल, और इसके अलावा जो हमारे बृहद संहित में उल्लेख आता है वज्र लेप और वज्र संघात का, उसके बारे में भी प्रकाश डालते हुए मैं मनोज जी से आग्रह करूंगा कि वो इन सब विषयों के बारे में बोलें।
So when it comes to construction methodology, I would like to give some details which are not popularly known, because for anybody in the modern days, we have some fixed notions about constructing any structure. But many of them may not be directly related to chemistry as such, but these are informations which have to be known by students of all the fields. So firstly, talking about this tapatis, this is one thing which everybody should know, because in today academics, we are usually introduced to one branch of knowledge, and the person will be specializing or concentrating only on that particular branch. He wouldn't know even an iota of any other field. But in ancient days, the Stapatis were not like that. They had to know, a lot of geological aspects to determine whether this stone is suitable for building. They had to know iconometry, the measurements. See, you may imagine they have to make a pillar which is about 6 feet tall of hard granite stone. They will have to select a stone which is at least 10 feet. Because of the sizzling and rotting, many of the things will be chipped off for the design they have to achieve. And that should be very hard. It should sustain the weight of the structure. It is not decorative. It has to sustain the weight of the structure. Then it has to be transported. So they have to calculate all these aspects. So they had to know the nature of the stone, the quality of the stone. And there are many temples built by dynasties like Nolambas and others, where they have used a softer stone just to build the door jambs and some decorative windows, perforated windows and others. So if the stone is soft, then naturally the sizzling and intricate designs can be achieved. But the structure needs stability. So keeping that in mind, selecting a stone for the stability of the structure, as well as selecting stones for decorating the structure, both was simultaneously done in a very efficient manner. And many a times there is a question, have they been checked, or is there any proof for these things? The structures themselves standing for more than 1,000 years without any damage itself is the proof to show that they had achieved that amount of efficiency in building structures. Now coming to the construction methodology, another thing which many of the modern people would not have the idea is, at least in temples, they never went too deep in the earth. The foundation was not always dug too deep. See, today if you are building a structure, they build a basement with huge pillars, and they have some distance between the pillars, and that is the way it is being built. And many times still it is unsuccessful. But even if you are heard of Brihadeeshwara temple in Tanjavur, the height of the temple from the plinth is 200 and odd feet. The superstructure itself is 180 and odd, so below that. The entire structure is standing on the ground, and the foundation beneath the ground level is just 5 feet. So they never went too deep inside the ground level. And again, texts talk about how they begin, there are separate chapters where they begin with the selection of the ground where you are supposed to build the temple, how hard it should be, how it should be tested. So you should dig some pits in the selected ground, fill it with water, see how much of water it sucks, how much it leaves. So this shows us how strong the ground is so that you can plan a temple.
So when you say that the Brihadeeshwara temple's basement or even olden temple's basement was only 5 feet deep, is it because of lack of technology that they could not go deeper? Or was there some other methodology by which they felt, okay, fine, this is enough to sustain a structure of that high?
Actually, I don't think it was a lack of technology at all. Because if they can carry almost a 5-ton stone to 188 feet, so digging deep wouldn't be something very difficult. And one more thing is, if you see Ellora for that matter, it's a monolithic temple. The entire temple is monolithic, where you have all the adjuncts in the elevation on plan chiseled out of one particular monolithic rock. So it is not the technology part. See, they mainly, there are two aspects in the construction methodology. When it was built in stone, we have to understand no form of adhesive was used to bond the stones. They were all basically placed one above the other purely with the calculation of gravitation. The wall thickness would be very wide. So they did not feel the necessity to go too deep. So that's why, to understand the construction methodology, what do the text suggest for a builder is, it says you have to prepare a very hard ground above which the structure has to be built. So they say once you select the ground and you go a few feet deep, then you lay a set of boulders which are of the size of an elephant head. They have to be arranged. In between, you fill with some pebbles. Then the second row, you have to arrange stones which are of the size of a horse head. That layer, you have to then fill the in between with pebbles. So like this, you get about 2-3 layers, which is very tightly built and fit. And above that, you will have a pavement of very dressed slabs. So even this, for the structural evidence, two things we have to observe is the existing temples in complete form. But to understand construction methodology, always the dilapidated temples are more helpful. That is where we can really know, because how this thing was planned. So after this, the entire plan, or the Vinyasa Sutra as it's called, the contour of the plan was designed and it was paved with stone slabs. Then the structure above it was built. And every intermediate phase, they used to see to it, strength is given to the structure. In stone, when it was built, usually the wall of the temple itself used to have 3 layers. So one was called as the Antarbhitti, the outer one was called as the Bahyabhitti, and in between, as you were showing in this previous slide, debris were filled. They mentioned that. You can fill it with debris, but you should be cautious that no vegetation grows. So naturally, when you are filling mud and other things, pigeons have the habit of putting some grains or something inside the wall. So water should not seep inside the wall. All these things were taken care of, and then the foundation pit was filled, paved, and then there are actually the Vimana, or the main sanctorum of the temple, is usually referred to as the Shadvarga. It has.
Sorry to interrupt again. When you say that the construction has to be done in such a way that vegetation should not grow or water should not seep in, because that is something in cutting edge today, that you need to have some hydrophobic surface so that it repels water. So could you throw some light on how they made it preventing water?
As I was mentioning about the 6 parts of the temple, of these, the lower 3 parts constitute the terms you need not be very serious about, but just for my convenience, I have to use them. So Adhisthana is the plinth or the foundation part. Then comes Bhitti or the wall proper. Above that we have Prastara or the entablature. So knowing Prastara construction will help you to know how water is not, so it's seen that water is not seeping inside the structure. So the wall usually will have two layers. In between the layer it will be filled with debris. The outer layer becomes very decorative. One more observation we have to make is only the visible face of the stone will be dressed. Whichever is put inside, because the antarbhitti or the inner wall, the outer face of it will be very crude and rough, it will not be dressed. Why don't dress this? When you are placing one above the other, it will not move or shake. If they are very well dressed stone slabs, then you will have something to hold to, which has to hold it together. But when it is not like that, you are planning it based on gravitation theory, all the stones will be well arranged. So even in between these walls, say just for an example, say you are building a wall which is about 10 feet tall. The wall is 10 feet tall. In between what they do, though it is 3 layers, Antarbhitti, Bahibhitti and whatever, they see to it, in between also they will put some stone slabs and cover the lower walls debris, so that some water or something will not seep in. Then they will build the upper portion. In between they would have left gaps for koshtas. Koshtas are niche, which is made to keep either divine sculptures or decorative sculptures. They will make the koshtas. So even the koshtas, they will be, the side walls will act as a protection for these two walls. So in all the ways, they see to it, the debris are completely encompassed with stone slabs. And the third part is the prastara, which is, these are all, utilitarian parts of the temple. They are not just decorative, they are utilitarian also. They give stability for the structure. So prastara means actually the entablature or the ceiling part, where we build the ceiling of the temple. While building the ceiling, the prastara has 4 components. The first component, the lowest, whenever we are talking about the components of temple, we go from the lowest to the uppermost. So, the lowest one is Uttara. Uttara is the beam which supports the pillars inside, above which the ceiling slab is placed. Then we have what is called as Vallabhi. Vallabhi is a semicircular moulding which actually extends a little further from this Uttara, that is from the plumb line of the wall, to support the upper moulding or adjunct, which is called as the Kapotha. So Kapotha is the main adjunct which protects the temple from water seeping inside. So Kapotha are extended prominently from the plumb line of the temple wall. We have to understand that. So it projects, say if the temple wall is receding by 6 inches, half feet or something from the plinth, the kapotha would be extending almost, say, about 3/4 or 1 feet from this thing. And they are not just, they don't leave, they don't say that no, we have built a kapotha and that will drain down the water. No. In between, above the kapotha, they have what is called as the vajana. Vajana has another name in the text called as Prachadanasya Asya. Prachadana means covering. Asya is the face. It is the face of the covering. In that, they will completely cover the temple with the ceiling. This will be seen throughout the structure, from sanctum to the assembly hall. And when this is being built, they will give what is called as the ambumargas. Ambumargas are water chutes. They are given in intermediate intervals, from where if there is rainwater or something, or even if you clean it, this water drains down directly without entering the structure. So these are all the precautions taken by them to protect the structure.
Thank you, sir. Finally, this is very intriguing to know that you mentioned there was no adhesives used while binding the stones. That is something very important that we need to keep in mind. Secondly, I mean, you can, for the benefit of students here, you can see the panel which is described as chemical names from Sanskrit. And I've shown you some chemistry terms which have come from Sanskrit. Now, by listening to what Dr. Manoj was saying now about this prastara, about this kapot, you had a term called kapota. And in all the European architectural norms also, you will see cupola. So you see these two words being very. So it's a matter of, you can go back and do some research and say whether it was parallelly existing or one has borrowed from the other. Having that aspect aside, so finally my question to you would be, what this Brihad Samhita talks about Vajra Sanghata and Vajra Lepa. So if stones were, no adhesives were used, then what was this used for? And with that we will close this discussion.
Vajralepa was mainly used only in case of the votive sculptures. So whenever a votive sculpture, suppose there was, actually we have this tradition which everybody knows, broken sculptures cannot be placed in the sanctum sanctorum. And there is one more thing, Vajralepa as an adhesive for an entire temple will be a very Herculean task, because the temples are very huge. So Vajralepa, as far as the Shastra Granthas mentioned, which into my jurisdiction like the Agamas or the Vastu Shastra Granthas, it is mostly used for the sculptures than the structure. So Vajralepa is one which is used in the repairing a votive sculpture. Here I just want to add one more point. When it comes to the structural stability, we have to think of one more thing, that is rain and other things. Okay, rain and shine, it is there, but there are other natural calamities like thunder and lightning, or even earthquakes for that matter. So the temples of many of the temples have survived these calamities also. So it is mentioned that above the stupi, when you are above the shikhara, that the pinnacle of the superstructure of the temple, you fix an adjunct which is called as the Purna Kalasha. It is textually called as a stupi. So when you are implanting it, when you are fixing it, they say you have to use a knob made of copper of such and such a length. So this use of copper as a metal, they say it helps the structure. It protects it from other things like thunder and lightning, and wherever necessary, wherever the most strength giving parts are being built, maybe pillars, or so at such points you can use a metal knob to fix. To metal and iron is never advised. It should either be bronze or copper. So this is about the sustainability from other natural calamities.
Thank you, sir. So, Dr. Suresh, would you like to add some final comments about, we have the corpus of ancient knowledge, as well as construction is an evergreen process. So long man lives, he needs to construct. So how do you think this ancient knowledge about the material science and chemistry involved will take it forward for the contemporary practice as well as a roadmap for future? What are your comments on that, sir?
Actually, the property of traditional materials to establish, we don't have enough labs, enough testing laboratories as well as testing facilities and experts for this one. That is the main problem. Otherwise, the whole traditional material would be used double than that of now, I think, because the traditional material have very good properties. The main thing, inside room atmosphere is the most acceptable part. Because when we are living without air condition, we can live in a traditional building. But without air condition, we cannot live in a concrete building. That is the problem, because they are not at all considering the environment, outside environmental condition and availability of material. They are not at all bothered about the energy how much we are using for constructing this one. In that way, it is not at all environmental friendly. That is the main thing. Now it is now everywhere, even in Western countries, going for sustainability. Actually, the sustainability concepts originates from Bharat.
That's a very contrasting image because I think this is the right panel and from which we can take it to a white paper or a policy document that be it water standards or be it even standard for making feet, we did not have our own standards. There is one institute in Jaipur which makes legs, for people who have lost, and it seems till now we have not had standards of our own Indian people. We have been looking at standards from Europe and America. So even this is a kind of a starting place where we can think of a roadmap. Dr. Manoj ji had mentioned that the test for the pudding is in its tasting. That the very fact that the structures have stayed for 1,000 years is the proof for their strength and efficiency. But I understand what Dr. Suresh is also saying, that we are bound with certain standards, and those standards are dictated by some other, arising out of some other policies. So it's high time for us to think of Atmanirbharta, that we define standards from indigenous methods. Right? We are bound by those standards, and that's why we're able to fit the traditional things there. That part is well taken care of. So I think this is the right platform for which we can think of defining those standards itself, by which we can harness or make use of the traditional materials in the future to come. So in that aspect, I put the same question to Dr. Manoj, how this traditional knowledge can be taken forward.
No, actually, that's what I wanted to share when he mentioned, see, it is not that we have neither lost our traditional knowledge or we don't have the lack of dearth of people who know about it. The only thing is they have to be linked. That is the problem. I'll just quote an example here. Archaeology people, they are conserving temples in the archaeological method set by the British parameters. Till date, they have never bothered to take consult of some agamikas. We have very good agamikas. So, the only thing is you have to make the archaeology people understand that you should take the suggestion of an agamika, and we should make the agamikas understand that archaeologists are there to conserve the structure. This link has to be made, nothing else. We don't have the dearth either of the source, and especially in this the digital days, everything is the fingertip, but people using it are not there. That is the really disheartening thing. So only thing necessity is to find the proper people who have this knowledge and try to utilize them. See, we go behind certificates. We are more concentrating on what is there on the paper and print. And those people, many times, they don't bother about your paper and print, but they will be very much thorough. The entire Mayamata, they may be knowing orally. Entire Tantra Samachaya, they may be knowing orally. But we don't go to them because they are not certified. This is the problem we are facing now. That link has to be really created.